I have two pieces of information. I have good news and I have bad news. Which one do you want? Okay, the bad news first. Unfortunately, Vasco missed his flight, so he's not here. The good news is Peter is ready to go. Everybody, Peter from Jump Cloud.
Should I just get started or wait at all or just go? Okay. Hi, my name's Peter Gengler. I work at Jump Cloud. You heard me talk about us hiring before. I'm an engineer there. We do directory as a service, so you can think of this like AD next generation in the cloud. We're located in downtown Boulder, right next to Boulder Theater. And as mentioned before, we're hiring, so come see me if you want to ask me questions. I'm going to chat about something we built called gRPC Q. The first thing to talk about is the why of this. So as everyone kind of knows, there's this industry trend towards microservices, taking these big monoliths and breaking them apart into separation of concerns and domain-specific services and stuff. It's great for kind of building safer code and being able to scale horizontally. But this large distributed system can have problems, namely communication problems. At that kind of scale, you're going to fail talking back and forth with each other. And so a way to kind of solve that is the concept that these synchronous requests are not necessarily durable. You can do retries, but you're kind of bound by this request response cycle the client's expecting. So a very common pattern to solve this is to move that work off into a queue that is durable, where you can do it asynchronously, you can process it later if you need to, etc. To solve this problem, you might find out there are a lot of queue frameworks. They're similar to HTTP frameworks, you know, so there's a handful of those in the Golang world. And they're meant to handle common functionality, right? No one wants to write a TCP listener that knows how to construct HTTP messages and that kind of stuff. You want to pick something that does the heavy lifting code for you. And writing queues is no different, right? You want someone that knows how to serialize and how to deserialize and how to attach handlers and stuff. And there are ones out there. So, you know, when I was thinking about this problem, I went and did a little bit of research and looked around, and I found this one called GoWorker that's kind of like Rescue if you're familiar with the Ruby world. It has this serialization, deserialization definitions you can use. You register handlers kind of like you would in the HP world. But one thing I didn't like about it wasn't super type safe, and didn't have a lot of gray abstractions around things called brokers and queues we'll get to in a second. Another one that I went and looked at called Machinery. Again, kind of this arbitrary mesh format. You can define some deserialization and serialization around that. They improve by having this kind of concept of pluggable backend brokers. So think of like SQS or RabbitMQ or Redis. And again, you could register these workers, but not type safe. And there are lots of these, just like you can find a dozen different HTTP packages and frameworks. There are lots and lots of those. So when I was thinking about that and trying to think about if I wanted to pick one of those or what we want to do in our kind of need for this queuing framework, I took a step back and I said, hey, what do I want a queue framework for? Like, why do I want this? What are the kind of wish lists of things that I would like? And so I kind of boil those down to automatic serialization and deserialization, right? Like, I don't want to be in the business of writing that code over and over and over again for every microservice. I want to have this kind of easy way to handle requests. I want to say, hey, there's this concept of a user insert, and I want this to be able to handle that request. There's a user delete, and I want this to be able to handle that request. Some bonus things I was looking for that you can kind of aim for in the Golang world is type safety, right? A lot of these products in, like, say, Ruby or Python are going to avoid type safety, and you kind of have these runtime assertions. And if you look at some of the ones I mentioned before, they do the same kind of thing. They say, hey, we're going to give you a request, and then you serialize, or you type assert it to whatever you want to be, or you use kind of helper methods to say, I assume a string, and if it's not, it'll panic at runtime. I wanted kind of to avoid that if possible. And then I also wanted to abstract out, like the Machinery one did, the concepts of brokers and queues. So I don't want to be tied to one queue implementation. I wanted something that knew how to say, I'm going to give you a message and you store it for me, and then I'm going to ask you for a message and you can give it back to me. And this all boils down to something that I kind of personally believe in a lot around these frameworks, which is I really want to write the code that's for my application. I don't want to write all the other stuff around that. I just want to, if I want to insert user, I want to write the code that knows how to insert user, and I don't want to deal with the other pieces around there. For people who are familiar with it, this might sound a lot like gRPC, a fairly popular framework in the Golang world, as well as others. As a side note, I'm going to describe this a little bit, but I also gave a talk on this a while back. There's a link in there, so if you want to get like a deeper introduction to what gRPC is, beyond what I go into tonight, you can kind of go take a look at that talk down there. In that talk, I talk about how gRPC is really about making type-safe generated code. So instead of using these reflection or typecasting type assertions, they generate code around an IDL. They chose protobuf as their language that they're using. It has binary serialization as well as ability to define services. And then they make a bunch of the glue code for you. Interface definition language. So DSL might be another term. And we'll see an example. I have a protobuf file that we'll look at. Oh yeah, I forgot to mention this, but I don't mind interruptions. So if you have questions as I go along, feel free to stop me and ask me anything. So gRPC kind of as a high level, it's this interface definition language, define messages and RPCs that can interact. So from that previous slide, there might be a user object. You might pass that to an RPC users.insert or users.delete. They implement a server. In the case of gRPC, it's over HTTP2, and they give you the ability to register implementation-specific handlers against that server. And then they implement a client for you, again, over HTTP2, that has the ability to send these RPCs. Again, the goal being you are going to write your application-specific code, which we'll see in a second, and not anything else. I kind of realized, hey, that's my goal with a queue or messaging system. So why don't I write something that handles those same RPCs in that same language, but does it over brokers and queues as opposed to HTTP2? We all good right now? How many people have heard of gRPC, by the way? Yeah, that's what I thought, yeah. That is why I didn't go into too much details on that. So as I said, gRPC queue, we use the same IDL for gRPC. One kind of nice side effect of this is that it's trivially easy, as we'll see through some of the examples, to write code that both supports a synchronous and an asynchronous worker. The messages themselves don't change. The callees have auto-generated code that can handle that. They just say, hey, I want to send this off and I want to wait till it's done, or I don't want to wait till it's done. It introduces concept, nothing super new in kind of messaging frameworks or queue frameworks, of a broker, which is the transport, the thing you talk to, like SQS, and then a queue, which is like a named identity for producing and consuming messages. And then we implemented a consumer, so all that kind of boilerplate code that knows how to do consumption and common patterns around that, and the ability to register these RPC handlers for the messages. And then we also implemented the other half of that, which is the producer, and the ability to kind of produce these RPC messages to be handled by various consumers. So we have a common language for chatting. This gets back to the question about the IDL. This is protobuf 3. In here, we're defining a package called proto. We make a service, which is their like namespace for methods called test. We define an RPC on it called test RPC that has a message type of a request and a message type of response. And then we just define those messages. They have a lot of different kind of flexibility in what you can put in these. I just made it have a simple string that message that would come in and echo back out. And then the next piece is an implementation. So this is really the goal of all of this, is to write this implementation only and let it serve synchronous and asynchronous requests and have very little other code you have to write or create around that part. So I implemented the RPC. There are some gRPC and gRPC queue, therefore, use interfaces to make sure that you fully implement your services. So you get compile time assertions as opposed to runtime assertions if you're missing a handler on a service or something like that. And then they use, as I talked about, auto-generated code from the gRPC library in their world or from the gRPC queue library in our world to do a lot of the boilerplate. And then you have this ability to kind of write this service however you want to, right? So you can say, hey, I will handle test RPC. There's a line there, supposed to say test RPC there. You can say, I'm going to handle test RPC however I want to. You can do dependency injection to get dependencies there if it's going to talk to some data store, whatever you want to. You just have to meet the contract of I take a test RPC request and I return a test RPC response along with the context and error. And you get a bunch of benefits in this. You get type safety at compile time because you can't violate types and that kind of stuff. You're getting automatic serialization, deserialization of all the variables. There's some stuff you don't get, right? Like you still have to check if your strings are empty or your numbers invalid or that kind of stuff. But you get a lot of the benefits that you would have to normally do yourself with interfaces in some of like the other languages or other frameworks. So the first, oh, sorry. I thought you were telling me 5 minutes. No. Yep. So we generally make those meaningful, but protobuf, so Google exposes a set of oh yeah, sure, sorry. He asked, he said gRPC requires protobuf 3, which has took away the pointer types for the values such that the 0 values come through. So you can't tell the difference between someone sending you a 0 value, like an empty string or 0, and them not sending that value at all. It looks the same on the wire format to protobuf 3. And I was saying the way we handle that when we need to is Google exposes well-known types for proto messages. So they do things like a timestamp and a bunch of stuff like that. They have one called a field mask, which is classically used for that problem. So you assume that a 0 value was not sent unless it's in a field mask that tells you it was sent. It's the same strategy that Google uses on like their admin SDK stuff for sending HTTP responses or HTTP requests with JSON. Essentially, it's like, sorry, the question was, what is a field mask? It's essentially a map. So it's a map of field names to whether they are meant to be enforced or not. So the implications, if it's not present, you treat this 0 value as not present. And if they say, hey, username true, and I send along a blank username, then that means I'm supposed to clear the username.
Any other questions? Just put up your hand. I'll bring it up.
Cool. All right. So from that kind of IDL we define and that service we defined, I'm going to show how the gRPC server part works. So this is Google code. It's supposed to be very simple. You, again, no error handling like before because it takes up space on the slides. You listen on a TCP port. It's going to use HTTP2, so it's going over TCP. You create a gRPC server. You register this user-specific server implementation, and then you serve requests. And so the kind of neat part of the takeaway from this slide is that the first line comes from the standard library. The second line of code comes from the gRPC library code. The third line is auto-generated for you so that it takes the gRPC server as well as an interface that meets the protobuf definitions you had. We implemented service on the previous slide, so that's the piece of code we wrote and pass in. And then the last line comes from the gRPC library code. So you had to kind of wire pieces together here, but you didn't have to write any specific handlers. And the only stuff that's really unique to us in this world is that we're listening on a port of a specific number and we're tying in our implementation of that particular interface's service. So in the gRPC queue world, we have a consumer, predictably parallel to the server. You dial a broker in a queue. In this example, I'm just pretending there's an in-memory one, although in reality, you'd be using something like RabbitMQ or Redis or SQS or something like that. You then create a gRPC consumer, and then you use a similar method that's auto-generated by the library to register your service on that consumer, and then you start consuming. The parallels to the previous code should be pretty obvious here. And again, the first part of it is gRPC library code, or it could be third-party code if someone wanted to implement their own kind of queue and broker that wasn't supported. The next line is gRPC library code. It knows how to create a consumer that does kind of common patterns. The next line is the auto-generated register service, takes the consumer and the service implementation interface. So again, that's code we wrote and then pass in here. And then finally, we consume requests off of that queue. So again, only pieces in here that are unique to us is the queue we're listening on, the broker we're using, and the service implementation we tie into the consumer. So internally, we use Redis for like development use, and then we're using SQS right now in Amazon. There's been talk about whether we want to look at some of the ActiveMQ stuff once they release that, but no, not advised. But yeah, and I actually gave this talk a little while ago, maybe a year or two ago, and I went into more of the details of the actual implementation of it. So I'll post that afterwards so people can look at it. And you can kind of see how the pieces just glue together. But in there, you'll see that the broker and the queue are interfaces so that you can pass them in. It follows the kind of the factory. Well, we use the factory pattern internally, and then it follows the constructor pattern kind of thing in there from the last talk. So it's all asynchronous in the consumer producer world, right? And then the synchronous half would be the existing gRPC stuff, which is the server and the client. So, and what we do is we actually, write the code such that you instantiate all these services once, and then when you're writing the API server, you tie them to a gRPC server, and when you're writing a worker, you tie them to a gRPC queue consumer, so that everything can handle any message, and it's really the person producing it that gets to choose which one they're going to use based on their need, basically. Mm-hmm.
Between like Redis, I don't know the durability of SQS, but how would you ensure say you like swap in something that's pretty durable like Kafka, sure durability, but that's
Yeah, that's exactly the idea. I mean, we wrote Redis as like a proof of concept and to use for like local development because you don't have external dependencies. SQS has a bunch of durability promises and that kind of stuff. Not as robust as say a Kafka, but also significantly less complicated. So, pros and cons. But yeah, the idea would be that you would swap in a message broker that meets your kind of needs around those particular questions, right? There's also things around, say, partitioning and that kind of stuff that are important when you're trying to figure out how to balance that load across these workers.
So we've got one more question. And if you want to ask a question, just put up your hand. I'll bring over the mic.
Are you able to support unidirectional or bidirectional streaming from gRPC?
Well, not the stream. So we didn't bother doing the streaming since most of the requests are asynchronous. I guess, is your question around the neatness of their bidirectional streaming, or is your question around getting responses back from the asynchronous requests? The latter one? Oh. So we didn't bother with that because we don't have a lot of use cases where that kind of connection time is a big hit. Plus, some of the brokers would have to kind of support that to some degree too, right? So SQS, for example, is really just HTTP REST endpoints. So there's no bidirectional stream benefit from like a network round trip and that kind of stuff, right? If you kind of wrote your own, you could probably manage that stuff, but we hadn't really explored or done any of that thus far. Yes, there are exactly 2 more slides that are probably fairly predictable. But any other questions right now? No? All right. So then we will move on to the next half, right? So we did the server, which is taking requests, and the consumer, which is plucking them off a queue. The next half, this equation in the gRPC land, is the client. So this is what sends a request, a synchronous request. In this world, you dial a server. So you say, hey, gRPC, dial up this server. You then create a typed client around your protobuf definitions. You make a request that's also typed with the fields and whatnot. You make the request with a typed method. You get back a typed response, and then you can kind of handle it. And again, the takeaways from this is that first line is all gRPC library code. The second line is completely auto-generated from the protobuf files. The third line, you inject, kind of the data you want, but the message is defined as like a Golang struct, so there's type safety around that. You make the call, again, type safety on the typed method test RPC, and then you get back a response that also is a struct that has typed fields and whatnot like that. And as predicted, the next slide is the producer, right? Extremely analogous to the client. So again, we dialed the same queue that the consumer's listening on. Again, you can kind of decide that topography on your own application needs and whatnot. But in this case, I'm down the same in-memory queue and making the broker. I then create a typed producer, just like a typed client. It's going to have methods that are mapped to all the RPCs that are defined on that service. I make a message that has my kind of application or domain specific values that go in there. I call in queue, and then you'll notice the kind of slight difference here is that it's asynchronous, so I don't get a response back right away, right? I put that in a message queue, and that will be handled at a later point in time down the road. And just like the client code, the idea here is that the first 2 lines are from either the gRPC library or a third-party implementation for some other queue or messaging system. The next line is strictly from the gRPC generated code. The type or the request generation, you inject your own data in there, but it's also generated code that has strong types, and then you enqueue it with a method that's auto-generated via the kind of normal Proto-C compilation path. Any questions on production? Okay, sorry, what's your? Yep. Because I forget to repeat their questions.
So I'm just conceptually trying to see where the gRPC part of it ties in, and it seems like it's more just piggybacking on HTTP v2 to talk to a broker.
So HTTP2 is not kind of involved. You're talking directly to the broker.
Right.
I mean, if you think about gRPC kind of at the nuts and bolts, it's really about the code generation part of it. So like their magic is really the implementation of an HTTP server and client that do smart things. So things like the ability to add on transport layer security and do retries and have middlewares around retries and that kind of stuff. And then they generate code that's type safe for you. So that's kind of the gRPC magic that's outside of like a normal HTTP server. And in this world, it kind of parallels that in that the gRPC queue part is the implementation of the consumer. So like, you can spin up in the background multiple concurrent workers if that's what you want to do. You can control retries and timeouts and all that kind of stuff. You can put in middlewares for logging. You can add on encryption for kind of at-rest security, etc. So it's doing all that kind of boilerplate stuff for you, and then it's generating a little more code to help you have type-safe ways to interact with those. So
code gen probably is the big piece.
Yeah, exactly. Yeah. So gRPC uses a tool called Proto-C. It has like a plugin model. So you say, hey, Proto-C, use the Go plugin or the Java plugin or whatever. And then it auto-generates a bunch of code for you that has all these kind of type-safe benefits and whatnot. And so we essentially wrote our own Proto-C plugin that ties onto that and adds more code in that does this stuff.
It would be kind of cool to have like a gRPC interface to any sort of underlying broker, and you'd have like plugins that would go to any broker. So you're just talking gRPC to a thing, and whatever's underneath can consume that. So you don't have to deal with things like Kafka's crazy, insane protocol, low-level stuff. That'd be kind of cool.
Yeah. And I mean, this is kind of an attempt at solving that in a slightly different way. We didn't kind of abstract it as much as that, but the idea being the shared code is very small and similar, so that you can affect that without a ton of extra work, basically. Any other questions around it? No? All right, so that's mostly it. I'm just going to summarize it. So the idea of this project was gRPC-like patterns, but for asynchronous requests. So you can use that. It shares a lot of generated code with gRPC, so like we don't regenerate the structs for messages and that kind of stuff. We're basically just generating things for producers and consumers that are specific to those. And then due to time constraints, there's a bunch of stuff I didn't show on here, which is, lots of times you want to get back the response somewhere to this asynchronous path. So we have a kind of method to tie in an asynchronous path and then receive those messages and do things with them. Partitioning is pretty important to us because we want to ensure kind of fairness across our queues. There's a bunch of middleware needs we have around things like logging and tracing and metrics and all the kind of normal things you might want, and et cetera. And then I am currently working open source this. We're at JumpCloud's kind of in that startup-y phase. So that kind of depends on how much time I get, which is not super available. But it is hopefully going to be out there for people to use somewhat soon and kind of contribute to if they wish. Not yet, no. I mean, it's not what I would call IP, but it's just a matter of getting through the legal lawyer people and convincing them and doing all the crossing the T's and dotting the I's. Any other questions? No? All right. Thank you very much. Oh, sorry.
Oh, hang on. We got one question.
Last minute edition.
Thanks for your talk. I just wonder if you might talk a little bit about like tooling and things that you found using gRPC itself, less about the queue, but more about your experience with gRPC. And also if you have time to like also talk about why you chose gRPC over other RPC frameworks like JSON RPC or Avro or something. If I have time, I can. Yep. Okay. So I'll start in the second one there because it kind of leads into one, I think. So the question was why choose gRPC? It sounds like a lot of people know about it, so they probably know some of this. But we were really looking for, like I said, something that took away a lot of that boilerplate code. I wanted it to be type safe, so it took advantage of Golang's benefits for compile time. And then we use, we're a polyglot company. We use mostly Golang, but we have a couple legacy services in different languages. And so the appeal of being able to define these interfaces for microservices once and then easily use them in different languages was very appealing to us. So JavaScript, a little bit of Python, and a little bit of Java are all kind of in use. So that intercommunication was a big part of picking gRPC. We started using it fairly early. Oh, sorry, go ahead. Yeah. So the question is, do we evaluate other code generation frameworks or kits or whatever you want to call them? Yeah. So yeah, I went and did like kind of a survey of a bunch of ones. GoKit was one of them. There's a couple there. I liked GoKit a lot, but it felt like that was more heavyweight than we necessarily wanted. I felt like I could start with something like gRPC and then back my way into those kind of more pieces. Which kind of segues in your second question, which was the tooling stuff. One of the weaknesses, I think, of gRPC when we started using it 2-ish years ago or 3-ish years ago was a lack of kind of community support around it. So there wasn't a lot of like necessarily tooling. And so we ended up building a lot of that, right? So we built in kind of tracing layers. We built in a lot of the logging layers, a lot of the application layers. Some of it kind of came around, right? So like once some of those good Prometheus plugins came in, we used those for a lot of the gRPC stuff. But we ended up doing a lot of that
early on ourselves, which was kind of a downside. But also I had the kind of feeling that the community was coming along on those paths. And we never really kind of got to the point where I felt we needed the extra, what I'll call a layer of abstraction that something like GoKit provided. I mean, it had a lot of flexibility, but it had like a kind of one more layer of abstraction than we particularly needed, I thought. So that's kind of how we arrived there. Go.
Boom, last question.
All right.
Load balancing. How do you deal with it?
So load balance on the way into the key or on the way out or both?
No, load balancing gRPC. Oh wait, you're not using you're using gRPC as a transport also. Right.
Well, I mean, we are using.
You're using TCP. You're using HTTP2 as a transport.
Yeah, I mean, outside of gRPC Q doesn't have any of that, right? That's talking directly.
Well,
to
there's
the
a client-server relationship, right?
I mean, they're on the front end. There can be, right? So like,
you definitely have clients.
Yeah,
gRPC clients, and you have gRPC server.
Well, so for example, like a lot of our requests come in through like an ELB in Amazon, and then translate into a backend request to the gRPC queue. So in that world, there's no strict gRPC communication. We do use it a lot for internal kind of microservice communication.
How do you deal with load balancing there?
Right. So we started getting into console and using the client-side load balancing. Although we've been recently looking at switching over to kind of more of a proxy-based model because I guess headaches around the client-side load balancing don't seem quite worth the benefits traded off against something like Envoy or now HA proxy. Envoy. We've started looking at, we're not using it in production yet, but we've started playing around with like in development stuff. And then HA proxy 1.8 supports HTTP2 in a much better way. Yeah, that's the big problem, right? HA proxy 1.6 and mostly 1.7 don't support HTTP2, so you can't really use those. Nor do a lot of the classic load balancers in AWS or Google. Yeah, exactly. But then you miss a lot of the benefits because they have long-lived connections to the backend.
All right. Okay, everyone. Let's have a round of applause for Peter. Thank you so much.
Thanks.
Okay, I have a suggestion. Let's all take a 10-minute break, compose ourselves. There is one limitation, though. You cannot leave the building, because if you do, you cannot get back in. Where can they go?
Yeah, so the downstairs lobby is plenty cool. Pretty much anywhere outside of this exact room. Like if you go into the hallway a little bit, please don't go around the entirety of SendGrid, just the areas that are kind of blocked off for your access. A lot of those are plenty cool, but the lobby is plenty cool. You can hang out down there. Lots of cool air.
Okay, so we will see you back here at, let's say, 10 minutes past the hour.
That was a great talk. What do you think?